SpaceX had a major screw-up. Booster B-16 crashed into its stand, messed up an engine, and crushed part of the rocket. Flight 10 is a no-go. People are saying it's a total mess. But this is where Elon Musk usually surprises everyone. What seems like a huge setback for SpaceX might actually be pretty smart. The fix? Just some crazy good engineering. So the static fire test went great. 6 Raptor engines fired perfectly for a full minute, perfect data, perfect everything. Then, bam, disaster. B-16 was being lifted from the launch mount. This huge rocket, 200 tons, was moving super precisely. The stand's hydraulics were fine, everything looked good, and then the control system glitched for just a second. But when you're moving a rocket taller than Lady Liberty, a second is a long time. Crash. The back of the rocket slammed into the stand. It sounded like thunder at Starbase. Metal hit metal. Precision engineering met reality hard. An engine got crushed, fuel lines maybe broke, and heat shield tiles scattered everywhere. SpaceX's worst fear came true. But get this, what happened next is nuts. This wasn't just any booster getting hurt. B-16 is 3 years of work, of people pouring their lives into this rocket. The money lost is huge, the timeline probably got longer. But Elon? He was quiet. No panicky tweets, no trying to control the story, no press conference. Just quiet for 2 days. Everyone was waiting to see if Flight 10 was dead. If SpaceX's try fast and break stuff thing had finally gone too far. Turns out, everything was okay. SpaceX wasn't freaking out, they were planning. Here's what was happening behind the scenes. While everyone was looking at the broken engine, SpaceX's engineers had already thought of what to do. They weren't just fixing it, they were upgrading everything. The engine nozzle that got crushed? Gone. They put in the newest Raptor, which is more powerful, better, and more dependable. The fuel line check? It found tiny cracks that would have made the thing explode in the air. The crash actually stopped Flight 10 from blowing up. The broken heat shield? A chance to put on the better thermal protection they wanted to use. Every problem became a way to make things better. But the smartest thing? It was happening at the same time on the other side of Starbase. While B-16 was getting fixed, S-36 was also getting changed. The ship that was going on top of the messed up booster was getting the best upgrades ever. The extra layers on the heat shield aren't just fixes. They're new protection that takes everything they've learned from past flights. The longer inspection time, perfect time to put in better computers, better navigation, and better landing stuff. The delay everyone thought would kill the mission? It was giving SpaceX time to build the best Starship ever. 2 vehicles, 2 fixes, 1 great plan. Here's where things get really cool. The engine replacement wasn't just a swap. SpaceX used it to test how they build engines. Instead of setting them in place, they used quick disconnects. Now, swapping engines only takes minutes, not hours. You can fix things in the field, and missions are easier to change. The damage to the grid fin? That led to better stuff, too. New materials that can take more heat, wings that land better, and better controls that make every landing smoother. The fuel system check? That made SpaceX create ways to see leaks in real time, so they can watch the fuel while flying and prevent crashes. Every issue became a reason to create something new. Reality check. SpaceX engineers were facing a June deadline, the FAA still had to say yes, and the launch window was closing. Other companies were trying to catch up, and people were watching closely. One bad move and SpaceX's try-fast thing would fail. Most companies would have played it safe, delayed things for months, run tests, and covered their butts by doing things by the book. SpaceX? They went all in and were very brave. Teams worked all the time. Some fixed B-16, others fixed S-36, the legal teams handled the FAA, and the manufacturing teams built backups like a Formula One pit crew, but with rockets. So, instead of waiting months, they made all the changes in weeks of crazy work. Here's the story nobody's talking about. The accident made SpaceX make its biggest leap forward. The transport stand crash made them rebuild the way they handle vehicles. They made new stuff to make things safer in the future. The engine damage became a way to test new ways to control engines. They figured out thrust changes that will make landing on Mars doable. The delays let them put in systems to keep things from falling off, going above and beyond what the FAA wants. Future flights will be cleaner, safer, and better for the Earth. Every problem became a reason to create something new. This one thing didn't just fix B-16, it changed how SpaceX builds vehicles. They aren't just building rockets, they're building spaceships that fix themselves. Future starships will carry spare parts, fix themselves in space, and know when things are going to break. The B-16 crash wasn't just an accident, it pushed SpaceX forward. So where does that leave Flight 10? B-16 is stronger than ever, better, more dependable, and more advanced. S-36 is the best Starship ever. Better heat protection, better navigation, new landing systems. The FAA is actually okay with it because SpaceX made things safer. The big question, will Elon's brave bet pay off? Or is SpaceX risking it all on something that hasn't been tested? The answer is the next static fire test. If B-16 works perfectly, Flight 10 launches soon with stuff that makes older missions look old. If something goes wrong, we'll see if Elon Musk's ideas were right. Everyone is watching to see if SpaceX can turn this disaster into something amazing because SpaceX is different. They don't just deal with problems, they get better because of them. So, here's what's up. When B-16 crashed, it showed that SpaceX thinks differently from other space companies. Normal space companies see problems as problems. SpaceX sees them as materials to make new things. Are we seeing the start of a new way to build things, where accidents become good things, and problems become times to make breakthroughs? If SpaceX can turn a broken rocket into its best one, what else is doable? Mars seems less like science fiction and more like something engineers need to figure out. The point isn't just to fix B-16, it's that space travel doesn't have to be slow. It can go faster because of mistakes. What do you think? Will space travel finally be freed from the slow way of doing things that has held us back? SpaceX's hot staging had a dangerous flaw. A huge steel ring made things explode in every flight. Engines were firing very close together, shooting out hot air that could break the rocket. But SpaceX didn't stop using the system. They made something so clever that it makes the old design ridiculous. They turned a danger into their best thing. What was wrong with SpaceX's hot staging? During early tests, engineers saw that every hot staging was making explosions inside the interstage. The upper stage's 3 Raptor engines would fire while trapped inside a steel box. The hot gases had nowhere to go and they would crash around inside, making pressure waves that could break the rocket. It was like lighting a torch in your garage and closing the door. 3 Raptor engines made a lot of thrust, and the hot air was hot enough to melt steel. All of this was happening very close to the protective dome. Most rockets separate with a lot of space, but Starship was doing it with almost no space at all. The engineering team knew they were playing with something risky. That protective dome was heavy because it had to be. Every pound of the steel ring was there so it wouldn't break. Without it, the pressure would crush the dome. Lighter materials would fail completely. This thing weighed more than 3 Falcon 1 rockets. That's crazy for something that's supposed to make the rocket better. The thing that was supposed to boost the rocket by 10% was actually making it worse because it was heavy. SpaceX was stuck. Make it lighter and it breaks, make it stronger and it's pointless. They found a way out during Flight 9. They did something that seemed dumb. They blocked vent holes. Why would you trap more pressure in something dangerous? They weren't just fighting the pressure, they were learning to control it. By blocking vents, they could make the exhaust go where they wanted it to. This moved the 250-ton booster in the right direction, giving them total control. This also showed how dangerous hot staging actually was. The pressure was so intense that it could throw a rocket around like a toy. They were fighting confined explosions. Someone at SpaceX started looking at old Soviet rocket designs from the 1960s. The Soviets used frameworks that supported upper stages without adding weight. But the Soviets didn't have to deal with hot staging. SpaceX decided to use triangular lattice frameworks. What if